Hi everyone, welcome and thank you for joining us at today's webinar, Enabling Effective Coatings Formulation to Improve the Durability of Assets, presented by Huntsman's Advanced Materials. So this is a series of 3 webinars, and today we will cover tanks and pipes. I am Olivia Fallet. I'm Operational Marketing Manager for Coatings and Constructions at Huntsman. So before we get started, let me just go over some housekeeping. Okay, so the presentation will last about 45 minutes and we'll have some time at the end for Q&A. So if you can see on the right side of the WebEx screen, we have a Q&A feature. Feel free to submit any questions throughout the presentation. We will also share the slide deck by email after the webinar, but the recorded session will be available on our website in the next couple of days. If you would like to discuss any specifics of a project with our team, you have a few options. You can just let us know in the chat located at the lower right corner of the WebEx screen. So it's a little hidden, so that it's in the corner. You can also go through our website and through the Contact Us section, or you can just reach out to your local representative. Also, we would love to hear your feedback, so please share your thoughts by completing our survey at the end of the event. All right, so let me introduce our speakers for today. We have Mr. Yong Zhang. He's our Technical Manager for Coatings and Construction. Yong has over 20 years of experience in the coating industry, holding 2 patents and author of multiple publications. Mrs. Kirsten Steinmeier is our Global Strategic Marketing Director for Coatings, Constructions, and Electronics. Kirsten has over 30 years of extensive experience in the coating industry, holding multiple roles from research to marketing. All right, so moving on to our agenda for today. We will cover why durability is important. We'll discuss some of the challenges for the formulator, how to overcome viscosity, brittleness, and degree of conversion to achieve high-performance formulations. We'll then summarize the discussion and open the Q&A. All right, so that's what we plan for today. So Kirsten, can you kick us off today?
Sure, I can. Thank you very much for this very nice introduction. So the durability of pipes and tank linings can be reduced between 30 to 50% when the coating is exposed to extreme conditions such as, for example, strong acids and high temperatures. So as a consequence, asset owners have to almost continuously invest into coating repairs, which is not only expensive but also is taking valuable time away for the assets to be in use. So to extend the durability of those highly exposed coatings, we have been working for several years and developed over those time frames the multiple components which significantly can increase the chemical and thermal performance of pipe and tank coatings. So can you maybe go on to the next slide? Thank you very much. So what we depict here is basically that highly durable coating performance requires to influence the overall glass transition temperature of the coating system, its mechanical strength, toughness, and cross-linking density, while ensuring reduction of the overall volatile organic compound content and still staying SVHC-free. So we will cover those development aspects in our presentation, and we will kick it off with the influence of polymer design on coatings performance. So, Yang, now your turn. Can you maybe tell us more about that?
Sure. Thank you, Kirsten. Hello, everyone. Thank you for spending time with us today. Like Kirsten mentioned, to design a high-performance coating with a good durability, especially for heavy-duty applications, there are many factors we need to consider. We're going to highlight some key elements during formulation design and introduce several unique products, which we hope you will find interesting and were included in your formulation toolbox and for any future product design. So now let's get started from some basics. So we all know epoxy resin-based coating has been used many years for industrial protective applications because it has a very good adhesion, excellent chemical resistance, and very good mechanical properties. So if we look at the epoxy structure, we can find out why. So in this epoxy standard BSA type structures, we can see we have those aromatic rings, which give us the structure stiffness. It also gives us temperature resistance. And because it is hydrophobic, so it will also give us very good corrosion resistance. We also have OH group in the linkage, which gives us very good adhesion, and that is why epoxy resin has an excellent adhesion to various substrates. We also have ether linkage here and the two methyl group here, which give us overall stability and good chemical resistance. Of course, we have many different epoxy resins we can choose when we design our formulas. Some is aromatic, some is aliphatic, and some is in between, like cyclone aliphatic. We also have different functionalities. So if we look at the aromatic type of resin first, and by increased functionalities, we have better chemical resistance. We also improve the TG. But in return, we usually have higher viscosity, and we also will have some breathiness issues. On the other side, and if we moving epoxy resin from aromatic to cyclone aliphatic to all the way to aliphatic type, and we have a lower hardness development, we will also reduce the TG, which will impact the chemical resistance. But in return, we have lower viscosity, and we have a better flexibility, and also we have a better UV resistance. So you always want to take the right resin for your end applications. So for heavy-duty applications, a lot of times we want to choosing high functionality epoxy resins. And this slide tells us why high functionality epoxy resin is important. So if we're using just a linear system, such as two functional epoxy with two functional amine, we have this kind of very linear structures. On the other side, if we're using three functional epoxy resin, four functional amines, so both high functionality system, instantly we have this high crosslink network. So it's very similar like this image on the right side. So with high functionality, we get a very good crosslinking density, which will give us very good hardness development, give us high TG, and give us better chemical resistance. But at the same time, it will shorten the pore life, and dry time is also reduced. So again, for heavy-duty application, we want to using high functionality to give us those high performance, but sometimes we will run into high viscosity, breathiness, and short pore life, those issues.
So thank you very much, Yong. So in summary, the aromatic content leads to hydrophobicity and good thermomechanical properties. As you've shown, the hydroxyl group support adhesion formation, and the ether group within the epoxy cannot be hydrolyzed, which is good for chemical resistance. So in addition to that, as you just explained, high functionality leads to high cross-linking density and as a consequence delivers durability. But increased functionality can also lead to high viscosity of the formulation. So how best to manage this effect, we will hear now in the following chapter.
Yes, to manage viscosity without impact performance, and we usually suggest two ways. One is using low viscosity epoxy resin, but with high functionality. Another is using high performance diluent. So here we're going to talk about low viscosity epoxy resin with high functionality first, and then we're talking about high performance reactive diluent in later slides. So in this slide, we're listing several epoxy resins here. And you can see the y-axis is cross-linking density, on the x-axis is adhesion. And the size of the bubble is proportional to the viscosity. So if we look at this Alloy GZ290 XM90 epoxy resin, so it has a lower viscosity, very good adhesion. So it is fatty acid modified BSA type epoxy resin. So give also very good flexibility. So it's very good for the corrosion resistance. So for like anti-corrosive primer or DT and primer, this will be a good choice. If we're looking for good chemical resistance systems, we want to considering Novolac. And we have several great Novolac epoxy resin you can choose. For example, we have Alloy 8350, which is high functionality, is about 3.6. But if we look at the bubble size, this one also has a very high viscosity. We also have like Alloy A240, for example. So this one has a lower viscosity, and the functionality is still about 2.4. So we can have a good crosslinking density, but without a very high viscosity, to manage with. We also have another resin such as Alloy PY302-2. So this is kind of a bis-AF mixture type resin. And so it has lower viscosity than typical bis-A type resin, but it also has a better chemical resistance than typical bis-A type resin. So sometimes we're using this kind of a resin for floor coating applications. So the product I want to highlight in this slide is XTREME PY2100. So you notice this one has a very small size, bubbles, because this resin has a very low viscosity. So its viscosity is even below 1,000 cent points at the room temperature. And this one also has very high functionality, give us very good cross-linking density. So this is exactly when we talk about using those low viscosity but a high functionality resin, we can give us opportunity to make formulation with 0 or lower VOC. So now here's more data about XTREME PY2100. So if we look at the left chart first, so we compare P2100 with Alloy GY250, which is a typical standard bis-A type epoxy resin. Like I mentioned earlier, PY2100 has higher functionality. So in this test, in both G' and glass transition temperature, we can see PY2100 gives much better performance. And if we compare PY2100 with Novolac on the right side, and you can see with this high temperature curing condition and curing agent we use, we can reach PY2100, the TG, by using PY2100, we can have TG as high, close to 200 degrees C. And it's even higher than high functionality Novolac, such as Alloy 8350. The TG is about, 180 degrees C. And if we comparing with low functionality Novolac, such as Alloy A280, the TG is even below 150 degrees. So that's a huge, TG difference here. And if we look at the x-axis, which is fracture modulus, and you can see PY2100 also gave us the highest strength in this comparison test. So this very unique product does give us kind of freedom to move the formulation to the next performance level. So now let's talk about reactive diluent. So the product I want to highlight here is Alloy DY31. So if we look at the comparison on the right side first, so we compare this 4 functional aliphatic type reactive diluent with another 2 functional reactive diluent. One is Alloy DY026. It is also aliphatic type. We also compare Alloy GE22. So it's cycloaliphatic type reactive diluent. And you can see using Alloy 20315 kind of IPDA-based curing agent, and the ultimate TG with 31 system, we can very close to 140 degrees C. So with only 2 functionality and the DY026, the TG is even below 60 degrees C. And with Alloy GE22, because it's cycloaliphatic structure, so it will improve the system TG, but it's still lower than 80 degrees C, the final TG. And further, we put the sample into the boiling water and we soak for 3 days. And then we check the water absorption. So the bubble size here stands for the water absorption. So you can see because of high crosslinking density, by using high functionality for DY31, the water absorption rate is about 6.6%. So it's better than 2 functionality 026, which is at 8.3%. And Alloy GE22 is 2 functional reactive diluent, but its cycloaliphatic structure, which improves the system hydrophobicity. So in this test, G22 has a better result. So now let's look at the left, look at the viscosity reduction effect by using the high performance reactive diluent such as DY31. So you can see the bubble size again is proportional to the viscosity. And so DY31 only has 300 cent points viscosity, so it's a very low viscosity. And if we compare it with novel X, like 8350, and you can see the viscosity is about 130,000 cent points. And if we reduce the functionality, we can reduce the viscosity to about 2,000 cent points. But the functionality now is also reduced to only about like 2.5. But if we're using mixture, and such as mixture of 8350 with DY31, so in this kind of a 60-40, mixed ratio, we can have a mixed viscosity is only about 10,000 cent points. And so this is even less than standard base A type epoxy resin viscosity at room temperature. And so the 10,000 cent points comparing 130,000 cent points, that basically means we reduction viscosity in 92%, right? But because the DY31 has high functionality 4, so this mixture we still have a high functionality is about 3.76, right? And so this kind of demonstrate by using those high performance reactive diluent, we can reduce the system viscosity, but without sacrifice the performance. Kristen?
Yeah, thank you very much, Yong. As you just heard, the use of multifunctional diluents plus specifically designed multifunctional resins like the XTREME PY2100 can help us to overcome high viscosity issues without losing chemical or high temperature resistance. But what options do we actually have to reduce potential brittleness of these highly functionalized and highly dense dried film without reducing the TG? Can you talk about that, Yong?
Yeah, sure. So to manage this, and usually we recommend 2 different routes. And one is using toughness, and another is using adhesion promoter. And so we try to improve the system overall adhesion strength. So here we're going to focus on using toughness. And the toughness we're going to talk about is based on reactive liquid polymer. So if we look at these structures, we can see, this kind of reactive liquid polymer basically is copolymer of butadiene and acrylonitrile. So the butadiene, here, bring us very good toughness and flexibility, even at lower temperature, because it has a very low TG, like minus 40 degrees C. It also gives us good water resistance. On the other side, and this acrylonitrile function will bring us, chemical resistance and the TG. And also because it's polarity, it will improve, the overall adhesion. And we also can add a different reactive end group and to meet the different end applications. If we look at the loading amount into our system, and we can see by adding, toughness, and we increase the overall system toughness, right? But at the same time, we start to see some bad, kind of impact in the glass transaction temperatures. So for example, if we're using 15%, per 100 parts resin, and we can improve the toughness is really good, and we start to see some dropping in terms, TG. And if we further increase loading amount, let's say we increase to 20% loading amount, and you can see 20% compared with 15%, the improvement in toughness is very minimal, right? But the TG impact is getting bigger, right? And so that's why we usually recommend you want to using between 5 to 15, this kind of a sweet spot as your formulation design. So this slide explains why and this toughness working. So without the toughness into the system, and the polymer matrix is just one single phase. So when crack happens, it will be very easily to propagate all the way through. Right? By introduce toughness into the system, and because it's incompatibility we kind of introduce the second phase. And this second phase is made by those rubbers, and so it's very flexible materials. So when crack happens, it will absorb, the energy, will stop the further propagation. So the two SEM image here on the right basically showing, we can disperse this micronized, reactive polymer into the matrix to overall improve the system toughness. So we have a broader range of toughness we can choosing from, and some is under HYPRO and some is under HYPOX brand name. So for HYPRO, for example, which is amine terminated, and so you can using this one add to the cleaning agent side, because for a lot of heavy duty formulations, cleaning agent usually have lower viscosity than epoxy resin side, and so by adding the toughness into the cleaning agent side, we can minimize the impact into the overall system viscosity. We also have a different epoxy-based type HYPOX toughness you can choosing from. And so, for example, we have HYPOX IM22, HYPOX IM20. So they are all low viscosity. If you want, try some low viscosity toughness. And if you are looking for high functionality, we have like HYPOX IF92A, which has functionality about 2.3. So this is based on base F type epoxy resin, so can have better chemical resistance. We also have other different viscosity you can choosing to meet your end applications. So now let's look at some data. By adding toughness, we can see the performance improvement. So on the left side, we're adding HYPRO 1300 X45 ATBM into the amine side. And so this reference we use is based on GY250 and iodide 140. Right? So by adding the toughness, and we can improve, the overall system adhesion, for example. Right? And so in this test, you can see we want left shear strength at room temperature, and by using toughness, we can improve performance almost 50% more compared to the reference control. At a lower temperature, such as -40 F, which is also -40 degrees C, you can see the improvement is almost doubled. We also noticed very good, improvement in terms of T-pair strength. So on the right side, and we're adding HYPOX IF92A into the epoxy resin side. So by introduce, toughness into the epoxy domain, we kind of overall improve the system mechanical properties. So here we measure the TG and the G1C. So in the reference, without any toughness, you can see the system TG is about 137 degrees C. And but the G1C, which is only about 200. So G1C is basically kind of energy to causing, the crack, right? And so if we introduce the toughening to the system at 45%, and you can see we can increase the G1C all the way to, almost like 900. And so that's basically is almost like a 5 times improvement, which means now you need much more, 5 times more energy to causing the crack, right? If we further adding, toughening into the system, let's see, we're adding 65%. You can see the G1C now is only increased to 1,000. So just another, kind of a 10% improvement. But we see the TG dropping now is from like 137 to 120. So we see the TG dropping is getting bigger. So we think, in this particular system, we would recommend using 45 as a loading amount. And you might think 45 is too much, but actually, for this HYPOX IF92A, we only have about 20% electromer content. So in the total final formulations, and they're still about only using like 9%. And so we're still within, that 5 to 15% range we mentioned earlier.
Using reactive liquid polymers allows us to improve adhesion, reduces brittleness, and that all without losing chemical resistance. And at the dosage levels of around 10% on formulation, as Yong just mentioned, the impact on the glass transition temperature is also minimal. So let's look at the effect of curing and glass transition temperature on chemical and temperature resistance of coatings in the following part of the presentation.
Yes. So when we design our formula and we're choosing our epoxy resin and the curing agent, and we need to consider, performance requirements, and we also need to consider the curing condition, because we want, our system and at the real world curing condition, and it has highest degree of cure. So this way it can hold the most performance it was designed to. Right? So if we look at the system on the left first, and we can see this is a ultimate high TG system with, the highest TG is about 180 degrees C. But if we cure this system at room temperature, and you can see, and the TG is about like 55 degrees C, and which is about only 60% conversion rate, right? And this means, and we still have a lot unreacted epoxy resin and curing agent left in the system, and which is definitely not good, for the overall performance. And so usually we would recommend the curing temperature should be at least 30 degrees below the potential TG, right? So for this high TG system, if we really want to pushing to the higher conversion rate, and you might want to cure at least like a 150 degrees C to have highest TG obtained. On the right side, and we have another a system and showing the curing temperature make a big difference. So this is a system with ultimate TG is about like 85 degrees C TG, right? And the same thing if we cure at 20 degrees C, which is kind of a room temperature cure condition. And you can see the TG is about only 55 degrees C, right? Still, kind of a big difference compared to ultimate TG, right? But if we cure at 60 degrees C, and you can see we can reach the ultimate TG, close to the 85 degrees C. And if you want to cure at an even higher temperature, such as 80 degrees C, and basically the ultimate TG is the same. The only difference is you just reach the ultimate TG in a shorter time, right? And so you always want to pick the right, curing agent, and so you can have a good degree of cure. So in addition, to the temperature, and there's other factors will also impact the degree of cure. And here we're talking about by introduce the pesticide into epoxy matrix, what kind of effect it will bring. And we all know people using pesticides such as nonylphenol or benzoyl alcohol into the formulation, and so we can speed up the epoxy and mean the cure, right? And it also will improve the degree of cure. So if we look at this chart, and you can see without any pesticides, and this system and ultimate TG is about like a 135 degree, right? But the conversion rate, you can see the conversion rate is only about like a 75, So when we introduce the pesticides into the system, and we can improve, the conversion rate, right? And all the way, if we're using 16% loading amount, you can see we can improve conversion rate to all the way to 95%, right? But at the same time, we drop the system TG to now is only about 75 degree TG versus 135 initial, right? And so we always need to find a good balance point. And when we introduce those pesticides into our system, we want to, improve the degree of cure, but we also want to maintain, the minimal impact in the performance, system performance. And so basically, we want to pick the right resin, the curing agent, and the good accelerators. And we also need to consider the different constraints in the real world application condition, and such as the VOC requirements, such as curing conditions. So we need to choose all those to adapt the different end application needs. So now let's look at the curing agent first. And on the left side, we list several curing agents. And on the y-axis is reactivity, and on the x-axis is VOC content. And some curing agents here, we contain, pesticides, such as, nonylphenol, benzoyl alcohol I mentioned earlier, and will be considered as VOC in certain regions. And you can see and the LI 33641 and LI 3064, they're all 100% solid kiln agent. And we have LI 355 here, so it has a very good chemical resistance and have good resistance to different solvents. It has about, like a 20% VOC content. And we also have another hardener such as LI 265-1, and this one has a very good resistance, for example, like high concentrated sulfuric acid. And this one has about like a 30% VOC content. And if we look at the chart on the right side, and so we list chemical resistance and application performance, and on the x-axis is adhesion and flexibility. And you can see, like ARADUR 364 has overall pretty good, chemical resistance. And for the chemical resistance, a lot of times it can be complicated, right? And so maybe, some hardener is very good in the solvent and maybe is not very good in the caustic. And some maybe is very good in the acid, but maybe not very good in some chemical, test, right? So you always want to pick the right kiln agent or combination for your end needs, right? So such as, 364, and it's good chemical resistance, but in some applications, we may find out the kilning speed is not fast enough. So if we look at the reactivity here, right? And so in this situation, and we may want to add some, LI 33641, just to keep, kick the speed up, right? In another example, for example, if we're using LI 2973 and for floor application, since it has a very good chemical resistance and a low viscosity, but for certain application, we might need to further boost the chemical resistance. So in these cases, you may want to consider either, either LI 355 or LI 265-1 to further improve the chemical resistance. So here is more data on this LI 3064 kiln agent. And you can see it is a benzoyl alcohol-free hardness, has overall pretty good temperature, chemical, and mechanical properties. It is approved under Petrobras 2912 specification test. And if we look at the table on the left side, you can see it has a very good overall, testing results. So for example, we can pass added cell testing at 80 degrees C for 2,000 hours. So if we look at the picture this side, and you can see both the liquid phase and both the vapor phase and the liquid phase, the panel is still looking good, after 2,000 hours. You also have very good table abrasion results, and the weight loss is, less than 70 milligrams. Good catalytic disbandment testing results, very good adhesion, and also, pretty good, chemical resistance like caustic, acid, and solvent. You can see the panel listing here, and other than the discoloration, the panel, they all looks, pretty good, right? So you always want to, choose this kind of high performance kiln agent for your end applications. And by the way, this system is based on the Novax blends, which is APRO 8280 and APRO 8230. And it is cured at room temperature for 7 days before all those tests. So another factor we need to consider, and in terms of formulation design, for improved degree of cure, is using accelerators. And people using accelerators and to keep up the speed. And so a lot of times we add accelerators with amine and with epoxy resin, and we have this kind of, quick kind of a dry, system. And because, accelerator is not have functionality, and so it will, cross-linking to the backbone. And so a lot of times those accelerators will also reach out to, compromise the system performance. So we designed a very special accelerator, which is 2950. And so we kind of build, accelerator function into the amine backbone, right? And we also, because of the low functionality with this special amine, and so we can speed up the cure, but also maintain the good part life. So if we look at the table on the right side, and if we compare, our special accelerator 2950 with industrial standard accelerators, So for example, in system 1 and system 2, and we all use the same mixed ratio, with the same epoxy resin, 78 parts with 100 parts resin. And you can see with accelerator 2950, we can still have a power life 36 minutes versus only 12 minutes for the reference control, right? So we almost triple the power life, right? But we can kill the system in 2 hours versus 8 hours. So we can kill, and also much better, right? And so you can see the similar change between the system comparisons 3 and 4. Like I mentioned earlier, and the accelerator 2950 has a mean functionality, right? So it will cross-linking to the polymer matrix backbone, so it won't leach out and compromise the performance. So here's a test, and we find out. So in this reference test, which is based on LI GY250 with IPDA-based kiln agent 2315. And this is in the reference, since we did not add any accelerators. And after panel was made, we make it into the small pieces, and then we soak into the solvent to see how many we can extract out. So in the formulation 2, with 7% accelerator 96-1, which is industrial standard accelerators, we can see the leach out is about more than 4%, right? And considering we add only 7% into the total formula, that means about 60% was leached out. If we look at the formulation number 3, and with accelerator 2950, and we're only able to attack the leach out, is less than 1%, which means about only 10% was got leached out, right? So with this kind of a minimized leach out, it will won't compromise the system performance, and such as chemical resistance or corrosion resistance. So on the chart on the right side, and we see how using this accelerator can improve the curing, especially at the lower temperature. So if we look at the room temperature curing condition first, and you can see at the 23 degree and dry to touch time without any accelerator, and in this particular system, and it's about 12 hours, 13 hours. But by adding 5% loading amount, we can drop to almost half, 7 hours. Right? At the lower temperature, such as 5 degrees, right? And so at this kind of a lower temperature, and epoxy and amine reaction is getting slower, right? So we need using more to really, keep up to kick the speed. So if we're using 10% accelerator 2950, and you can see now we measure the full cure time. So now the full cure time is less than 24 hours, right? If we further increase the loading amount and all the way to about the 20% loading, and we can drop the full cure time and to 16 hours. And so if we have example like a floor coating application, right, and which means even at a 5 degree curing condition, and we still can apply the coating and work on it on the same day. So that's a very good performance. Yeah. So those are kind of products we want to highlight today, and hopefully you will find that those are very handy in your toolbox as we do.
Great. Thanks a lot. Loads of information, Yang. So we just heard how we can maximize the performance of a coating by selecting the right resin and curing agents and boosting the curing performance speed through the use of accelerators without negatively impacting the overall coating's performance. So before we now go into our Q&A session, let me quickly summarize what you've heard today. So the formulation of chemical and temperature-resistant coatings for pipes and tanks requires a maximization of cross-linking density, optimization of viscosity and toughness, plus considering, as I just said, accelerators for improved cure when needed. As you can see on this slide, there we actually summarized the various brand names to the components which help you to achieve this type of balance in your formulation for the ease of orientation. In the following slide, we summarized in the toolbox for your formulations in such a way that they are selected and depicted according to their key benefits. So with that, thanks again to Yang for your detailed explanation. Let's move to our Q&A session. Back to you, Livia.
All right. Thank you, Kirsten. Okay, so I do have a few questions that came in. Let me ask. The first one here is XTREME PY 2100 a commercial product? Any samples available?
Yes, and yes, this XTREME PY 2100 is a commercial product, and we do have a sample available and for interested party to evaluate.
Okay, thank you. Okay, next one is, do we have to change stoichiometry when we use 2950?
Yes, and when we're using accelerator 2950, and it does has a mean functionality is about 75, and it depends your kind of formulation design, right? So if we only using very minimal, and for example, if we're using only like 0.5, and those kind of very minimal amount, which will also improve your reaction speed, and the impact into the epoxy and amine ratio is very minimal, so you don't have to change. But if you're using accelerator as kind of a second amine to really speed up the system, and if you're using more, for example, and like 6 gram, 10 gram, and so this time, and you need to calculate, the mix ratio to make sure you still have, the similar epoxy amine index ratio, so won't, impact the performance. Yes, so it really depends your end application and your formulation design. Yes.
All right, thank you. What toughener do you recommend to have a better chemical and TG retention?
Yes, so I think there's many toughness you can choose, right? And so if you're looking for good TG retention and good chemical resistance, you always want to choose the high functionality toughness. And I think during the slides I mentioned we have RF92A, which is based on the BIS-8 type and toughness. So you may want to try this one and to see if it will improves chemical resistance without hurting TG too much.
All right. Okay, next one. Do you have encapsulated amines for one-pack system?
I don't think we have, and I can double check internally and to make sure, and we can get back to you.
Awesome, thank you. What is the chemistry of DY031? Is it rich and TUSCA registered?
For that question, I'm not sure, and I need a double check, and we can have your information recorded, and we can get back to you.
Maybe I can step in here. From my understanding, it is certainly REACH registered. The TOSCA listing we would need to check, but it's certainly registered by REACH.
Thank you, Kirsten.
Okay, next question. Would this product also do well in bare metal flow coatings and industrial storage containers exposed to prolonged or horizontal water pooling? I am assuming that this question is more like a general question according to all the portfolio that we presented today.
I think in the bare metal flow coating and the storage tanks, and I think usually with those kind of Novlax and epoxy resin and a different clean aging, it will have overall pretty good resistance. And I think of course you need based on your end needs, and you want to pick the right resin and the right clean aging, but I don't think those will have any issue and for those kind of applications.
Awesome. Okay, have you noticed any dimensional changes when using accelerators?
That's a very good question. And so usually epoxy and amine reaction and, the volume change is minimal, right? And by adding accelerators, and we usually do not really measure. And we also, do not see the too much impact in adhesion, which sometimes, because the volume changes too much, it will affect the overall adhesion. But we did not see that. So.
Okay. Is ARADUR 3064 a commercial product?
So ARADUR 3064 right now is not. Right now it is a commercial product, but I think it is for our US. It is not TSCA listed, but we are in the process and to make it TSCA listed. And I think with everything right now is still under the timeline, and we are really pushing for this product. I think sometime first quarter or second quarter next year.
Thank you. I think I can jump in this one as well. But yes, so we should expect to have it available in North America second quarter of next year. All right.
Thank you.
Next question. Do you have any data by using Aradite DY31 in chemical resistance tests?
This is a very good question, and I think I do not remember if we have any data, but I can go back check and to see if we have any data by including DY31 in some chemical resistance test to see what kind of a performance we can get.
I think we have some data available in Europe.
Oh, great.
Mm-hmm.
Okay. Did you run any tests comparing RLP with core shell rubber type tougheners?
Yes, I believe we do have some internal data comparison and comparing, toughness, such as RLP we're talking about with some other, core shell rubber type of toughness. And we do have some internal data. And if you're interested, maybe we can, talk about in some other time. We can share more detailed information and with you guys.
Awesome. Do you have more data comparing accelerator 2950 with other accelerators?
Yes. So we did comparing, this unique accelerator 2950 with other accelerators, and such as, K54, DMP30, and those type of accelerators. And we do have some more data, and we also have a presentation and for Western Coating Show, and so we have some data in that one as well. And so if you're interested, we can share some more data and with you guys.
Awesome. So we only have, I think I have this last question. Do you have any toughener that can be used on the hardener side?
Yes. And I think during the slides, I did mention we have amine terminate toughness and HYPRO and ATBM and 1300X45 ATBM. And so this is amine terminated. And so you want to use this one to your amine site and to bring the system's overall toughness. And we also saw some applications and where people are using the both side toughener at both side, and sometimes they add epoxy-based toughener into the epoxy resin side, and they also add some amine terminated toughener into the cleaning agent side, and sometimes they also got pretty good results by using combination. So it's yes, we do have this kind of options.
Okay, so Yong, we're reaching out to the end of our webinar. We have just literally 1 more minute, so I will be closing the session right here. If you have additional questions, you can feel free to email to us or go through our website on the contact me section. So I want to thank you everyone for joining us today one more time, and we will be hosting a second session in the future, so just keep an eye for that. Thank you everyone.